So we have this frictionless ramp with frictionless pulley and massless pulley. M1 and M2 are connected like this. M2 may accelerate downward or upward. Suppose the positive direction is this way. Therefore, this accelerates downward, this accelerates up the ramp in the same way. We want to find the acceleration. Normally, you would do 3-by diagram for M1. Because the acceleration is up the ramp, it's better to take the x-axis parallel to the ramp. And then y direction this way. X and y for M1. And how many forces?
3.
3 forces, yes. This tension force this way. Normal force this way and perpendicular to the ramp. And weight is downward, right? And the angle of the weight with the negative y direction is again theta. And the acceleration is up the ramp. I put the acceleration here as a guide, which is in the x direction. So if I write sum of fx equal to max, what do I get? N doesn't have x component, so it's t magnitude, and component of w is mg sine theta, but negative, right? Because it is in that direction, equals to mass times acceleration. Magnitude, right? We don't know t, we don't know a, so we stop right here. But this is a useful equation. And then for the second object, M2, you take this x and y. You can also take the y direction downward if you want. Let's take y direction downward. That makes it easier because the acceleration is positive in this case. M2. And you have M2G and T upward. M2G downward and T upward, and you have the acceleration downward. So if y direction is downward, sum of Fy equal to MAY gives you M2G positive minus T magnitude equal to M2 times A. Right? Again, you get 2 equations. And then now if you add the 2 equations, what you get, t cancels out. You get m2g minus m1g sine theta equals to m1a plus m2a. You can say m1 plus m2 times a. Right? And now look at this. This is the weight of m2 pushing this way. And that's component of M1G pulling the other way. That's the net force acting on both of them together equals the total mass times acceleration. So you will be able to write this down from the beginning without doing any of that if you know what you're doing. You consider axis like this. This M2G is pulling this way. M1G sine theta is pulling that way. The component of weight along the ramp, pulling that way. The difference of those two is equal to total mass times acceleration. Okay. So you can easily find the acceleration from here. All right? So sometimes you can do that. That's a shortcut to find the acceleration faster. Does that make sense? Applying Newton's law directly for each one and adding things together actually makes you cancel the internal force, that is the tension force here. The tension force that basically M2 applies on M1, M1 applies on M2, right?